Hello everyone, welcome back to MindSpread. In the previous video, we discussed operations on sets. Those are things such as unions, intersects, and complements. In this video, we're going to be looking at properties of sets. But before that, a review of the last video is shown here. Alright, in this video, we're going to cover the properties. There's 7 properties and I've given them acronyms so that you can remember them easier. Let's cover the first 4. The acronym for the first 4 is CADI. C-A-D-I. C stands for the commutative property. A stands for the associative property. D stands for the distributive property. I stands for the idempotent property. Each of these properties have 2 rules associated with them, one for the union, one for the intersect. Let me show you. For the commutative property, let's have 2 sets A and B. The union of A and B is the same as the union of B and A, so the order doesn't matter. And the second rule will be for the intersect. The intersect of A and B is the same as the intersect of B and A, and that's the commutative property. Now for the rules of the associative property, we're still going to have 2 rules, one for the union, one for the intersect, but this time we're discussing 3 different sets, A, B, and C. Let's look at a union of A, B, and C first. If A is union with bracket B union C, then that's equal to A being union with B, and then being union with C. To remember this rule, all I remember is moving the bracket to the left. So in the first case scenarios, A is being union with the bracket B union C. If I move that bracket to the left, that would read instead A union B bracketed and then union with C. The second rule is the same as the first rule, but instead of the union, we're looking at the intersect. All the rules demonstrated in this video are all provable. To save time in this video, I'm not going to prove them all. Instead, I'm going to choose 2, which would be DeMorgan's Law, which will appear later in the video, and we will prove that together. Okay, we're on the final 2 letters of CADI. D stands for the distributive property. If A is intersected with bracket B union C, then that's equal to moving the bracket to the left, so A intersect B union with A intersect C. The second rule is if A is union with bracket B intersect C, that's equal to, again moving that bracket to the left, A union B intersect with A union C. I know I'm using the word union and intersect a lot. Just remember, union is the symbol that looks like a U, intersect looks like an N. Again, intersect, N, intersect. They sound similar, so the symbol is a N. Now for the final letter of the acronym, I for idempotent property. This is the easiest rule to remember. The intersect of A with itself is the same thing as A, and the union of A with itself is the same thing as A. That's it, that's the idempotent property. Okay, it's time for the final 3 properties. The acronym for the final 3 properties is UCE. How do we remember that? Well, if you look at the E and turn it 90 degrees clockwise, it would look like an M. So you can remember it as University College of MindSpread. MindSpread has upgraded from a YouTube channel to a university. So subscribe guys, because it's for free. You're at university for free, so subscribe. Anyway, let's carry on. The U stands for the universal property. C stands for the complement property. And E stands for the empty set property. Now before we continue, we need to discuss universal sets. You know how we're bound to our entire universe? Well, universal set is something similar to that. It's a set which contains all elements and objects of all the other sets. So for example, if these 2 circles represent sets, the universal set would contain them inside, and we represent the universal set as a big square. Why did you need to know that? Well, so you can understand what it means to take a complement of a set. If I name the 2 circles which represent sets as A and B, then the complement of A is U minus A. That means all the elements that exist that are definitely not A, and that's what's defined as the complement of A. And it's given a special symbol which is like a dashed line on top of the letter. Okay, let's apply it. If the universal set is the set with elements 1 to 5, and capital A the set with elements 1 and 5, then the complement of A would be 1, 2, 3, 4. Actually, the complement of A would be 2, 3, 4. There's been a mistake made here. Ignore 1 in the answer. The complement of A is elements 2, 3, and 4 because it contains all the elements of U, but none of the elements of A. Okay, there's a lot of rules for properties to cover, so I'm going to explain the most important parts instead. Rule number 2 and 4 of complement properties, the answer is U, which is the symbol for universal set. The symbol, which looks like a circle with a line going through it, is phi, and it stands for the empty set, the set which has no elements in it. The two rules for universal properties is if A is union with the universal set, then the answer is the universal set, and if A is intersected with a universal set, the answer is A. This video would be too long if I proved all of these rules by myself, so instead I'm going to prove two of these rules, which are known as DeMorgan's Law, and then what you learn from there you can use on any of these rules and prove them yourself. By the way, DeMorgan's Law is actually Rule 6 and 7 of the complement property. We will be proving that law very soon. The last box is the empty set property. Remember, if you turn the E 90 degrees clockwise, it looks like an M for mind spread. Okay, we're on the final part of the video. Let's prove DeMorgan's Law. One of the easiest ways to prove laws is to choose elements for the sets and see what we know about it. We're going to demonstrate it with DeMorgan's Law. DeMorgan's Law states the complement of A union B is equal to the complement of A intersected to the complement of B. Okay, let's assign these variables elements. Capital A can have the element 1, capital B can have the element 2, and the universal set can have the elements 1 to 4. Let's also draw the picture. The square box represents the universal set containing numbers 1 to 4. The orange circle represents set A, which has the element 1 in it. The pink circle represents set B, which has the element 2 in it. And the rest of the elements, 3 and 4, are inside of the universal set. Okay, let's see what's true about the elements. AUB looks similar to the top part of DeMorgan's Law. So what is AUB? That would be all of the elements of A and B, which would be 1 and 2. The complement of A and B would be all the elements that are not AUB, which is 3 and 4. The complement of A is all the elements that are not A, which will be 2, 3, 4, and the complement of B would be all the elements that are not B, which is 1, 3, 4. So now, if we look at DeMorgan's Law, we know what the complement of A union B is, and we also know what the complement of A intersected with the complement of B is. The complement of A, which is 2, 3, 4, intersected with the complement of B, which is 1, 3, 4, is just going to be 3 and 4 because those are the only two elements that they share in common. Therefore, we've proven DeMorgan's Law. The complement of A union B is 3, 4, and the complement of A intersect the complement of B is also 3, 4, so they're equal. If you made it to the end of the video, really well done, and don't forget to subscribe. I'm also running a website which deals with mental health issues. It's a blog and it's linked in the video description. Take care.